going on, guys? We have this question right here. It's asking find the absolute maximum and absolute minimum values of f on the given interval. The first question is f of x is equal to 2x cubed minus 3x square minus 12x plus 1, and they have given in the interval minus 2, 3. So let's see how we can do this. So first of all, we have to find the critical numbers. To find the critical numbers, we have to find the derivative and equalize to 0. So first of all, if I find the derivative of this one, f of x is f prime x is going to be I'm generally we use this format. When x power n, the derivative is going to be n x n minus 1. So that's how I am going to find all the derivatives. So let's see how we can do this. 6x square 6x square minus 6x minus 12, and derivatives 1 is going to be 0. So if you see any number, automatically the derivative is 0. Then we have this number, then I have to equalize this one to 0 to find the critical numbers. So if I equalize this one to 0, I have 6x square minus 6x minus 12. So I can, from the look of this, I can say I can simplify by dividing everything by 6. If I divide 0 by 6, it's still going to be 0. If I divide this side by 6, it's going to be x square minus x minus 2. Then I can factorize this one. So let's see how we can factor this one. I bring it to the other side. It's going to be x square minus x minus 2 equal to 0. So when I to factor this one, I have to find a number that when I multiply, I have to get negative 2. When I add, I have to get negative 1. Negative 2 and plus 1 will work. So if I do that, it's going to be x square plus 2x my negative 2 and plus 1 will work. So it's going to be negative 2. So x square minus 2x plus 1 plus x minus 2 is going to be equal to 0. Now if I take the x common, I will get x minus 2, and if I take plus 1 common, I can take x minus 2 equal to 0. Therefore the factors are going to be x minus 2 and the x plus 1. From this one I can say x is equal to 2 and x is equal to minus 1. These are my critical numbers, and then we have to check whether these critical numbers are in the endpoints. So they have given the domain that is negative 2 to 3. So we have to check these numbers are in the domain. So if you see 2 is within the domain, minus 1 is in the domain, so it's good to go. We are good to go. So we have to check now we have to check all the critical numbers and all the endpoints in the f of x and what's the value it's giving, and the highest value is going to be my absolute maximum and the lowest value is going to be my absolute minimum. So let's check all the values and see what's happens. So I would like to order them from the minimum to maximum. So the lowest value is minus 1, so lowest value is minus 2. I list that one first. Minus 2, minus 1, then we have 2, then 3. So if I if I plug the value minus 2 in this equation, I will get minus 3. And if I plug minus 1, I will get plus 8. And if I plug 2, I will get minus 19. And if I plug 3, I will get minus 8. Since if you look at this, all the values, you have to select the value that is lowest to select the absolute minimum. So if you see all the values, minus 19 is the lowest value. Therefore, this is my absolute minimum. Then to find the absolute maximum, we have to select the number that's highest value. So in this case, 8 is the highest number. Therefore, this is going to be my absolute maximum. So we have solved the question 47. Let's move to the question number 48 and see what's happened. It's same approach. I'm going to use this xn prime most of the case because all of them are there's nothing complicated in this thing. So all of them are easy to find the derivative. So let's find the derivative. F prime x 3x square minus 12x, and the derivative for any number is going to be 0, so I can just leave it as it is. Then what I have to do is I have to find the critical number. So in this case, to find the critical number, I have to equalize f prime x is equal to 0. Then if I do that, 0 is equal to 3x square minus 12x. If you see 3 and 12 are like, you can divide them, you can divide all by 3 to simply simplify this one. So if I divide 0 by 3, it's going to be still be 0, and if I divide this one by 3, it's going to be x square. If I divide minus 12x by 3, it's going to be minus 4x. Then if I bring it to the other side, it's going to be x square minus 4x is equal to 0. Now from this one I can take the x common, so x common is going to be x x minus 4 equal to 0. Therefore, this is going to be x is equal to 0 and x is equal to 4. So these are the two critical points. Then my next step is I have to check whether these values are within the endpoints. So endpoint is given minus 3 to 5 and 0 is within the endpoint and 4 also within that. So we don't have to worry about anything else. So these are my two critical numbers. So we are good to go now. So we have to check all the critical numbers and all the endpoints in the f of x to find out what is the absolute maximum and the absolute minimum. The highest value is going to be my absolute maximum and the lowest value is going to be my absolute minimum. So let's check all the values. I would like to list from the lowest to highest. The lowest value is minus 3 and the next lowest 0, the next lowest 4, the highest is 5. So if I plug minus 3 in the calculator, I will get negative 76. So basically what we are doing is we are plugging this minus 3 in the equation f of x equation and finding the value. So if I find the value for minus 3, I will get minus 76, and 0 it will give 5, and 4 it's going to give minus 27, and if I plug 5 it's going to give minus 20. Now I have to select the highest number and the lowest number. In this case the lowest number is minus 76, so this is going to be my absolute minimum, and the highest number is 5, therefore this is going to be my absolute maximum. Then you can go ahead at the end and say therefore my absolute minimum is f of minus 3 is equal to minus 76, or you can say, also you can say absolute maximum is f of 0 is equal to 5. So these are the two values you have to give. Then also in the previous question you have to do the same thing at the end, and that's it. I hope you guys liked this video. See you next time.